Hello and welcome to the first of the Partner Advocacy series with CJC IT. Today we're joined by the Data Analysis Bureau and myself. I'm George Hancock. I'm the Head of Business Development at TDAB, and I'm joined by Steve Moreton, the Head of Product Management, and Ivan Scattergood, the Head of Data Engineering. They'll be introducing themselves shortly, but today we're going to be talking around the work we're doing with CJC, how we work and operate as a partner, what that means for customers and what that's meant through this period of volatility that we've experienced for COVID, and what we're doing next, what advantages we bring as a data science partner, and what we're looking to do as part of our research and collaboration initiatives to sort of further that services with CJC, the wider partner ecosystem. So Steve, do you want to introduce yourself?
Yeah, thanks, George. My name's Steve Moreton. I am the Global Head of Product Management at CJC. We're a managed services firm operating across technical and commercial in the capital markets. We work with TDAB. We have a big data visualization system called Mosaic. TDAB have been there since day one. We take data from IT systems, put it into a time series database, and it comes out through this powerful front end. So it'd be great to talk about that a bit more in detail in a few minutes.
And Ivan?
Hi, my name's Ivan Scattergood. I'm the CTO and Data Engineering Director at TDAB. I've been working on the Mosaic OA project since the very beginning.
Great, thanks, Ivan. And so Steve, back to you. So what was CJC looking for in that partner, and how were TDAB introduced as a partner, and what sort of services were you looking for support?
So data visualization of IT systems, is IT analytics. It's been a sort of challenge for decades, really, and it still is something which is very challenging for a lot of firms. And what you need to do is you take data from IT systems, especially the specialist ones in the capital markets. We take the data from IT monitoring systems. We need to store it into a database for long term, and then provide it through a front end. And TDAB is the sort of secret source, as it were. You know, sometimes the front end is almost like the singer of a band. Like it tends to get a lot of the attention, but ultimately, you know, the songwriter and the musicians who are there, that they provide that data, get into that front end. And it's not just about the storage of the data, it's about bringing out the best of that data. You know, the hidden information, they're vast amounts of data to sift and sort through. So that's where we started to work back in 2015 with TDAB.
Great, thanks, Stephen. I mean, Ivan's been that hardcore band member since the start, Ivan. So can you just tell us a little bit about what the services we've delivered to CJC and that collaboration?
Yeah, now we've finally done our difficult second album. Yeah, so I mean, in the early days, it was just a matter of being able to collect the data at the rate it was coming in at. I mean, our largest customer we're actually collecting 5 million individual time series across 900 odd different servers. And so that's just collecting that data was enough of a technical challenge, and being able to present that to the user in a timely fashion. But the really interesting bit was when we started to find that, well, there's no way you can actually do anything with 5 million time series. There's no way you can sift through all that data. So what we were trying to do was find a simple way of identifying when things were being overutilized, or just as importantly, underutilized. Because if you're managing an estate with 900 odd servers, and you've got a handful which are being totally hammered and another small handful that are not being used at all, it would be great to be able to move those services around. And so what we came up with is our concept of the hot and cold servers. Now, the way this works is we collected metrics from 5 different dimensions, 5 different areas of each of these servers. So those 5 areas were the CPU usage, the memory usage, disk I/O, and network I/O. And out of those 5 elements, we built what we call the performance index. And the performance index allows it's a value between plus 100 and minus 100, and I'll explain why in a minute. But the idea is that if something's hitting plus 100, it means that it's really busy, and if something's at minus 100, it means it's pretty quiet. Now, to explain the idea as to why we picked that range, I'm just going to talk about a few of the statistical tools that we used. Now, one of the principles that we use is this concept called principal components analysis, which is quite a complex idea to grasp. But what I'm going to try and do is explain it in terms of some tools that you'll remember from when you were at school. And the first one is just the mean average. So this is what everyone thinks of as their average. It's just add up all the elements that you've got and then divide by the number of elements. So that's nice and easy. Now then there's this concept of a deviation from the mean, or a standard deviation. Now the point of the standard deviation is that it's a fixed distance from that mean. And so what you can and when I say fixed distance, it's based around calculations on that mean. So if you've got something in a standard distribution, what you may know as a bell curve or a Gaussian curve, you can see that a standard deviation is a set point away from the mean. And as you get a certain number of standard deviations away from the mean, you know that something is unusual. The variance is a concept where you're trying to say how much the values change. Now, one example that was explained to me was if I take a team of Dutch basketball players and measure their height, their measurements won't have a lot of variance. You know, you'll be going from like 6 foot to maybe 7.5 foot. So they're all quite tall. Now, if you threw in a group of school kids, their height wouldn't be varying. But if you can imagine, there would be quite a lot of variance between one group of heights and another group of heights. Okay. Now, but mathematically, variance is just the standard deviation squared. Okay. Now, the next step is this concept of covariance, which is the correlation between 2 variables that you're looking at. And you can see the covariances. You can see it as a linear relationship between the 2 variables. Okay, I'll try and describe that with this. So if you think of it in terms of back to our Dutch basketball players, chances are that a lot of professionally paid basketball players will be quite tall, and so if you've got there's probably a correlation between the salary of your Dutch basketball player and their height, because I'm not saying that you can't have short basketball players, but they're Dutch, so they're probably quite tall. So you've got what you're trying to do is represent 2 dimensions by a simple straight line. So the PCA attempts to draw a straight explanatory line through the data, like linear regression. Okay, so that's a positive covariance. Now, obviously, you have relationships which have a negative covariance, where things get smaller in relationship, but the principle is the same. Now, if I go back to those areas we were talking about, like CPU and memory usage, they're they're totally different scales and they're totally different measurements. So what we need to do is standardize and normalize that data. So if you can imagine you've got a number between 1 and 1,000, that's going to outweigh a number between 0 and 1. But you could imagine that you can actually normalize that between normalize a number between 0 and 1,000, normalize it down to 0 and 1. And then if you want to standardize something, we go back to the standard deviation. And what you're trying to do is standardize the distribution of the data around a central point. And what we're trying to do is say that CPU and disk IO, we can't compare apples with apples, because one's in 0 to 100% and the other one's in ranges from 0 to megabits per second. So you can't compare those two. So what you need to do is standardize and normalize those so they're both in a range between, say, centered around a 0 and going down to minus 100 and up to 100. And so that's what we did with all these variables. So we can now show you those 5 different areas, 5 different principles, all expressed as one number. And you can drill in and go, oh, that number seems high. Drill in and immediately say, well, the problem is that's using a lot of memory, or it's using a lot of CPU.
That's great. Thanks, Ivan. It's a real blast from the past there with some statistics. I almost thought we were going to get there. If Steve has 6 apples in one hand and 6 apples in the other hand, how many apples does Steve? What does Steve have? And it's Steve has big hands. That's what Steve has. Yeah, great. So Steve, what are the benefits? I mean, obviously there's a great feature set that Ivan subscribes. So what are the benefits to the CJC customers as well?
Oh, it's fantastic, and we do get a lot of compliments as we go to events and we meet data science team. You know, PCA is such a well-regarded sorting technique, and this is where a data science team is like TDAB just really understands what is needed to get the most out of this information. Ivan mentioned 900 servers. Those servers exist all over the world. You could have a region like New York, for instance, or London. And what you actually have is that those, let's say, 200 servers in New York, out of the 900, those 200 servers might belong to a particular business unit. So all of a sudden, they've been split in half, and then you've got 100 servers left. And then they belong to different infrastructures like Refinitiv or Bloomberg or Solis or XG. You can then put those servers in their own buckets and apply that PCA technique. So suddenly you've got your Solis servers in New York all being treated in their own bracket or in their own bucket, and you can easily see that this one server is actually working, or these set of servers are working much harder than the others. And the nice thing about Mosaic is you can then click on that server and you can see what's been happening over the last week or month or year on that particular server. You can apply that against application statistics and events, and it really becomes clear why that server has been working much harder than the others. And if a human being was to do that themselves, that would be a very brutal, long process, taking days or even, I dare say, weeks, whereas that PCA technique just takes just a few seconds.
Great, thanks, Steve. So that statistical application and that insight all gets distilled into a simple dashboard for people to take action, which is key, right? That data visualization is really important at all times, and obviously gives us that insight for general operations anyway. I think that's obviously been more important over the last couple of months through a sort of quite a wild period of volatility in the market. And what has that meant for your clients? So during this period of COVID-19 and lockdown and sort of unprecedented times, how has that enabled your clients to sort of respond?
Yeah, well, COVID, it was very well known that there was exchanges, vendors, investment banks, big financial carriers, all affected by this incredible amount of volatility. We saw some of our clients having, 167% increase in usage every day for almost 3 months. And Mosaic was already a critical system, but some of our clients were only getting statistics from other systems, 2 to 4 times a day, just saying, right, you have a concept called market data messages. So this is how many market data messages we've sent around our global environment. And some firms do 50 to 65 billion market data messages a day. And as COVID started to build, volatility started to build, it was becoming very, very clear that you were going to start hitting at some firms, you know, almost 100 billion market data. So that increased from 50, 65 billion to 100 billion. And these were truly unprecedented times, and it was very key that the client needed very, very moment by moment tracking of what the system was doing. So you had the history showing the fact that it had been 50 to 65 billion, but you had what is happening right now from a visualization standpoint. You also had the PCA technique where you could get the temperature of the server, and you can compare that from like the last month to the last few days, and so on. And we also had techniques where we could project where the data was going to be later in the day, and it was just became where more and more parts of the client's infrastructures, not just at one particular client, quite a lot of different firms, where you could just completely different systems were all seen as volatility. So it was very, very much a great thing to have a system like Mosaic.
I mean, it's great to sort of see the benefits that it delivers, right, to your customers, but it's not only just been the sort of finance and sort of capital markets that have been hit. Everyone's sort of seen a change, and I guess Ivan, the point to you is outside of that immediate application, what have you seen happen in the markets as well, and what have you and the team been working on during this period too?
Well, at the beginning of the lockdown, it was quite a difficult time because we'd actually been working on video analysis to help a company promote outdoor events, and also helping a company predict the outcome of tennis matches. And of course, both of those were cancelled this summer. So at the beginning of the lockdown, it looked like a bit of it was going to be a bleak time for us. But instead, we decided to grow our product offering, and also part of that was to provide a positive societal impact. And we've been working with Microsoft for a while now, and they introduced to us a company called Person-Centered Software. And they provide a digital tracking tool that is used in care homes, and it tracks information about the care provided to the residents of those care homes. And it's information such as the care home residents' appetite or their health, how much they've been drinking. And of course, during that time, they were collecting information about symptoms the residents were suffering from. And eventually, because PCS had developed a configurable solution, they were able to also capture direct information about how many people had been tested for COVID and who had come back with results, either positive or negative. Now, what we helped them do was build a set of dashboards and a way of visualizing that data that we could use to convince our government to send millions of tests out to these care homes. We've also been working on a mental health well-being chatbot. Now, the idea of this is that people who are working remotely now, as many of us do, are able to use this chatbot to ask questions about what they should be doing. I mean, now you're no longer having to go to an office, no longer going through a commute. How could you use that time more effectively? Is there things that you should do to make sure that you shut down after a hard day's work? And the idea of our SAM chatbot is it's collecting a load of information about the people who are interacting with it. And we're working with the University of Warwick and some mental health charities to provide actual support to human support for the people who are using that AI chatbot.
Brilliant, thanks, Simon. I think that, I mean, both great examples of initiatives of using data, right? And I think both play into that sort of data for good and AI for good that we really want to sort of champion and promote as well within organisations. So those projects are going to continue well beyond the lockdown. Hopefully, this is only a small blip in 2020. So when we look forward, what does that mean for CJC and TDAB? What's next for CJC and TDAB?
Yeah, I was, and that was great to hear actually, because, I really like positive use cases. I think sometimes AI and data science, there's some notable bad examples, and I think some people worry that they're being, tracked and in a negative light. So that's the positive, and I think that's where quite a lot of data science is actually used, really. And I think where you talk about care homes and people-based statistics, we're doing the same thing with server-based statistics. All we're doing is speeding up decision making, speeding up understanding, getting better understanding, this is where TDAB is able to apply these disciplines to whatever data set. So for ourselves, what we're looking at is that we're using Mosaic as a capacity management tool. We're using it to enhance fixes and improve understanding, but it's very human-led. CJC ourselves and quite a lot of notable clients are looking to use these tools to actually apply proactively and intelligently capacity management fixes, or just fixes in general, or uncover information we're not particularly aware as human beings. So this is where we've sort of laid the gauntlet down to TDAB again. We have provided, and we've got some great data that has been given to the full disposal of Ivan's team. So perhaps Ivan can give a bit more insight on what his plans are.
Yeah. So within TDAB, we have this innovation sandbox, which is our the way we interact with academia to work with the brightest young minds to allow them to understand real world problems and come up with solutions that we can use. So they will use technical problems that we provide them as part of their master's thesis, and we'll take those ideas and apply them back into the services and products that we're developing. And so one of the 5 projects we're running this year, we are working on anomaly detection within the data series that we're collecting for Mosaic. Now, I've said that term, but I think I better try and explain it. So an anomaly, if you remember when we were talking about, you've got time series data coming in, and the norm or the mean, the average value is in the center. Now suddenly, if there is there a change, and in computer land, what you're watching out for is, have I hit my disk limit? Have I hit my CPU limit? Have I bounded my CPU? Now, if that goes on for a short period of time, it's a pulse anomaly. So it's a sudden spike up and then a sudden drop down. And actually, in the world of computers, that's okay, because as long as your machine recovers from that failure, it's all good. The thing that you've got to watch out for are ramp ups and ramp downs, and this is where you've got a slow and steady increase, where you're slowly moving from a value which you are totally happy with, and moving towards a world where you're going to hit a boundary condition at some point. Now, the other interesting thing that we're looking at specifically is this concept of mean shift. So this is where you're going from a nice steady value, and then all of a sudden that steady value changes over a very short period of time, but it then becomes the new normal. So in the world of servers, this usually happens when there's been a release to a new server. Either the software's changed or some kind of process has changed that has alerted you to that. So what we're trying to do is, again, like with the identifying hot and cold servers, try and identify these anomalies automatically to try and allow the end users of the system to see individual trees within the wood.
Great, thanks, Ivan. So, I mean, that's going to be a great area of research and I guess application for CJC as well. So, Steve, what's that going to mean for you and your team?
Well, I think that was a great ending that Ivan mentioned, because it's like, you know, finding those trees in the woods, and there's that famous phrase, if a tree falls in a wood and nobody hears it, did it happen? And that's human led. It's a big known problem that you only know there's an issue when all of a sudden it punches you in the face, really. So we need to have all those trees being looked at, and that's where you need the system. There's just too much data for you know, not even, you know, sizable teams like CJC and some of our firms. There's just too much data to sift through, so you need a machine-led process. I will quote our clients, because obviously this is something that's being worked on as we speak. So if something good happens, show me it, type thing. So I think this will be, you know, really exciting basis of a future catch-up, I believe. So to discuss some of those results.
Yeah, absolutely, and it's going to be a really exciting area for us. Anyway, the Innovation Sandbox is one we're really sort of gearing up this year with new research students joining to look at obviously the anomaly detection, to look at the reinforcement learning for the Jack Trigger sailing projects, and natural language processing as well. So we'll be pushing a lot of stuff out through that Innovation Sandbox, and hopefully a lot of that is a benefit to the wider community of what we're really trying to look at. But obviously the end of the goal is to bring some of that insight into engagements like this, right? Make sure it benefits yourselves and benefits our wider customers and partners. And that, I think that's why we recognise it's great to be working with CJC in this capacity. And we know you have a number of other partners that you work with, which I think will be following up in this series, right? This Partner Advocacy series. So I think they'll be really good, really sort of powerful messages as well for everyone to sort of stay tuned to as well, and hopefully we'll be back as part of that series too.
Absolutely. Thank you very much.
Great. So on that note, let's wrap up, and I think thanks everyone for the time and for joining, and thank you both for your comments and your insight as well. So hopefully we'll bring back the trio again in a couple of months' time.
Great stuff.
Looking forward to it.
Okay. Thanks very much. Cheers.
Bye.